Hi everyone, welcome back to Aviation Tips channel, and whoever is new, welcome to this channel. Today it's gonna be a little bit redundant, so the video is gonna be very short, and we're gonna discuss critical engine and the factors that would affect critical engine if it fails. So, what is critical engine? The critical engine is the engine that, when it fails, most adversely affects the performance and handling quality of the airplane. And obviously, on most multi-engine aircraft, both propellers rotate clockwise as those conventional props. And by understanding the following factors when flying in the aircraft that has both propellers rotating clockwise, it will be apparent that a left engine failure makes the aircraft most difficult to fly than a right engine failure. And the clockwise rotation of a props contributes to the following factor that cause the left engine to be critical. Those factors are P factor, accelerated slipstream, spiraling slipstream, and torque. Number one is P factor. Let's start with the P factor and draw the plane here. Both engines are operating for now, and one aircraft on the right, engines are operating. P factor, I'm just going to quickly draw. In a single engine aircraft, most of you guys know the descending blade takes bigger bite of the air, pushes horizontally backward than ascending blade, and creates that left turning tendency of a single engine aircraft. Same thing here, but the effect on a critical engine is adverse when you are flying with the critical engine failed. So we're gonna go ahead and go with the on the left aircraft critical engine failed. So now at this point you have more thrust on the right side of the blade and then less thrust there. The distance to the fuselage is pretty much good distance, and it creates a good amount of asymmetric thrust to trying to push the nose of the aircraft to the left. And at that point you have to counteract it with the rudder. So you have a rudder counteract there, and you're pretty much putting a lot of rudder to counteract that engine. And if you have the turbocharged aircraft, you are almost putting everything in. So let's look at the critical engine. Now the right engine fails on the right side here. The distance is a lot less to the fuselage, and the push is not much, so you have asymmetric thrust, but doesn't so much pushes your nose of the aircraft to the right because the leverage, the momentum is less. And obviously you counteract it with a rudder, so you have more directional control on the right side, on the right aircraft here. And it's a lot better to, obviously you don't want to lose the engine, but hopefully we lose the right if in case we lose something, if we lose the engine. Coming down to accelerated slipstream. So as we said, P factor causes more thrust to be produced on the right side of the propeller. This yields a center of lift that is closer to the aircraft longitudinal axis on the left engine and further from the longitudinal axis on the right engine, and also results in less negative lift on the tail. And because of this, the roll produced by the loss of left engine will be greater than the roll produced by the loss of the right engine, making the left engine critical. So as we explained, same thing. It's more like a P factor, but it has its own type of thing. So we have failed the right engine. Same thing, center of thrust there. Let's say center of thrust right up here from the propeller, and we have again less distance here than if we would lose critical engine on this side. Let's say so we have less asymmetric thrust there, and you have rudder that counteracts that. And then the right side here, you have the center of thrust right around here, and that distance to the fuselage is a lot longer, so you have more asymmetric thrust that pushes the nose to the left if you have a critical engine failure. So I would definitely would like to wind up in this aircraft at this point in this aircraft losing critical engine. Coming down to spiraling slipstream, a yaw. I'm sorry. So here, accelerated slipstream, we will roll in pitch, and then P factor we yaw, and then coming down to spiraling slipstream. Your spiraling slipstream is basically a spiral slipstream from the left engine hits the vertical stabilizer from the left, helping to counteract the yaw produced by the loss of the right engine. However, with the left engine failure, slipstream from the right engine does not counteract the yaw toward the dead engine, and because it spirals away from the tail, making the left engine critical. How and why, I can draw right quick and to explain it better. So let's say you have a right engine. There we go. You have a center of thrust there, less distance, and then you have the left ascending blade produce less horizontal airflow. So as Bernoulli's principle, the air velocity increases, pressure decreases. So at this point, you have low pressure in here, and then high pressure here. So high pressure tends to seek low pressure, and they come around here. You have that rudder. You have more of a rudder effect, and it's just because hitting the horizontal stabilizer of the airplane, and you have less of a asymmetric thrust, so you have more directional control on this aircraft here. Then let's put it this way. Here you have engine critical has failed, and you have this engine, same thing. You have more thrust there, less thrust there, creates low pressure there, high pressure, trying to seek that. It goes away from the vertical stabilizer, and you have less directional control on this aircraft. So that is about your spiraling slipstream. Coming down to the last factor that affect the aircraft, multi-engine aircraft, the most when you have your critical engine an op is torque. And that would give you a roll. So as you guys know, Bernoulli's principle, for every action there's an equal and opposite reaction. Since the propellers rotate clockwise, the aircraft will tend to roll counterclockwise. When the right engine is lost, the aircraft will roll to the right. The right rolling tendency, however, is reduced by the torque created by the left engine. When the left engine is lost, the aircraft will roll to the left, and the torque produced by the right engine will add to the left rolling tendency, requiring more aileron input, which increases drag, making the left engine critical. So as your single engine aircraft, if you're flying single engine aircraft, the propeller rotates clockwise, the shaft try to go to the counterclockwise, and the whole airplane trying to go counterclockwise at this point. The same thing in your multi-engine aircraft. Right up here we have two aircrafts. On the left you have critical engine that's failed. The right engine is failed, and then you have critical engine failed, and the right engine is operating. So at this point, if you have your right engine is working, so you have about asymmetric. So the propeller's rotating to the right, and you have asymmetric thrust that is created, and then the whole everything else, the plane, everything, the engine trying to rotate counterclockwise, so that will help your rudder at this point too, with all the other factors. So this is good because you can maintain your directional control a lot easier compared to this aircraft on the right. When your propeller trying to turn to the right, now at this point you have obviously a symmetric thrust there, and your propeller's clockwise rotating, everything else trying to go counterclockwise. With your asymmetric thrust, at this point you have less rudder, and you have almost everything that you applied on the rudder there. So that would actually kind of set you in a position that you have a lot less control in this aircraft. I hope you guys enjoyed this video. I'm just gonna delete my previous video about the everything mashed together that I had. It was about the VMC, about the critical engine failure, about the P factors, these factors. So trying to make shorter videos. Hope you guys enjoyed. Thumbs up, like, subscribe. Please share. And we want to make better aviation out there, better pilots out there. And yeah, talk to you later. Bye.